Welcome students. In the previous class, we are discussed about the increasing order of the subshells in a shell. We are discussed that there are 4 subshells, that is S, P, D and F. These are the subshells that are included in a shell. So S is the common subshell for all shells and rather than P, D, F. This is the increasing order of their energy also. S the least energy and P greater than that of S, D is greater than that of P and the maximum energy for F. This is the increasing order of the subshells. And also we have discussed that the maximum number of electrons that are possible to accommodate in each subshell. In S subshell, the maximum number of electrons are possible to accommodate are 2. And in P subshell, that is 6. In D subshell, it is 10. And in the F subshell, that is 14. This is the last we are discussed in our class. Now today we are going to discuss about the filling of electrons in the subshell. The filling of electrons in the subshell. In the subshell, the electrons are filled in the increasing order of their energy. In the subshell, the electrons are filled in the increasing order of their energy, like what? Like in the shells. For example, that you know that the electronic configuration of carbon, that is carbon, its atomic number is 6. If you write the electronic configuration, we can get that 2, 4. What is it implies? 2, 4. The 2 electrons are filled in the first shell. First shell means the 2 electrons are filled in the K shell. Remaining 4 electrons are there. Remaining 4 electrons. That 4 electrons are filled in the second shell. The 4 electrons, remaining 4 electrons are filled in the second shell, that is in the L shell. So like the electronic configuration, we can write it as 2, 4. So the electrons are filled in the increasing order of the energy of shells. So this is called electronic configuration. That's we have studied in 9th standard. We have discussed that. Now today we are discussing about the filling of electrons in each subshell according to their increasing order. The electrons are filled in each subshell according to their increasing order. That is known as subshell electronic configuration. Okay, the distribution of electrons in subshells according to their increasing order is called as subshell electronic configuration. So if you write it is filling of electrons in the subshell, that is known as the subshell electronic configuration. Subshell electronic configuration. Subshell electronic configuration, that means the filling of electrons. The filling of electrons in each subshell according to their increasing order. Then we know that the first shell contain only one subshell, it is S. It is simply represented as 1S. And the second shell contain 2 subshells S and P, that is right as 2S and 2P. Okay, in these subshells we are going to fill the electrons. So that is known as the subshell electronic configuration of an element. Okay, so we are going to start our subshell electronic configuration. How we are going to write the subshell electronic configuration? For that we want to know the increasing order of energy of the subshells. The increasing order of energy of the subshells. The increasing order of energy of the subshells are, we are going to familiarize these things by writing the subshell electronic configuration. You know that the energy of S is comparatively less. Okay, so we are going to write the subshell electronic configuration of hydrogen. Its atomic number is 1 and that have only 1 electron. How we are write the subshell electronic configuration? If the atomic number 1, that implies that have 1 electron. So the first electron is always filled in the first shell. That is familiar to us. The first electron is filled in the first shell. The first shell contain only one subshell, it is S. So exactly the electrons are filled in the S subshell. So how you write the subshell electronic configuration of hydrogen? The subshell electronic configuration of hydrogen is written as 1s1. 1 S1. As we know the electronic configuration, that is 1. There is only one electron. Then how you write the subshell electronic configuration? The electrons are filled in the first shell. That first shell contain only one subshell, it is S. So exactly the electrons filled in the S subshell, that is 1. So we can read it as 1s1, 1s1. So left side, that is the shell number, S is the subshell, and 1, that is the number of electron. Okay, students, do you get the idea? The second one, if you are write your 5 or 6 atomic numbers, you can clear the idea of writing electronic configuration. Okay, listen. Next one, it is helium. Its atomic number is 2. Next one, it is helium. Its atomic number is 2. What is the meaning if you write the atomic number is 2? That means that helium have 2 electrons. The 2 electrons are filled in first shell. As we are, no. The 2 electrons are filled in the first shell, that is in the K shell. So now we are going to write the subshell electronic configuration. How we write the subshell electronic configuration? So that we know the electrons are filled in the first shell. The first shell contains S subshell. So the 2 electrons are filled in the S subshell. So we can write it as 1s2. 1s2. First shell contains S subshell that have the 2 electrons. Okay, so hydrogen is electron, subshell electronic configuration is 1s1, and helium is subshell electronic configuration is 1s2. The third one, that is atomic number 3, lithium. Atomic number 3, lithium. Some of the students also write like 1s2, that is they think it is very easy, and then we'll write 1s3. Is it right? Is it possible to write 1s3 is there? No. Why it is not possible to write 1s3? Because we know that the S subshell have possible to accommodate maximum number of electrons are 2. S subshell have maximum number of electrons are possible to accommodate is 2. S subshell 2 electron maximum ulkollu. Okay. Yes, the S subshell maximum possible to accommodate electron is 2. So we can write 1s2 up to 1s2 there. Then in lithium we can write what? At first we have to write what? 1s2. That means the first shell that contains S subshell, the maximum electrons are possible to accommodate there is 2. Then how many electrons are remaining? 1 electron is remaining. The first shell contains only one subshell, it is S. So next it is possible to fill in the second shell. The second shell, that is second shell contain 2s and 2p subshells. The second shell contain 2s and 2p subshells, which have the least energy. I just told you S is the least energy there. So 2s and 2p, if you compare the energy, 2s have the least energy. So in the second shell, the electrons are filling. The electrons first filled in the 2s subshell. Later it will be filled in the 2p. Okay, first the electrons are filled in the 2s subshell. After completing that, the electrons are filled in the 2p subshell. Okay, so students, please listen here. It is very important. If the atomic number is 3, if you write the subshell electronic configuration 1s2, one more electron is there remaining, electron is there, that is filled in the 2s subshell. So we can write the electronic configuration what? 2s1. So now the electronic configuration is 1s2, 2s1. 1s2, 2s1. From there we get the atomic number 2 plus 1. 2 plus 1, what is that? 3. 3 is the atomic number. Okay. The next one, beryllium, its atomic number is 4. Beryllium, its atomic number is 4, that have 4 electrons. We want to fill the 4 electrons. How you write S? We can start that. The first, the electron always filled in the 1s subshell, then we can write it as 1s2 because here it is 4 electrons. That's why we are writing what? 1s2. If it is 1 electron, you are only possible to write 1s1. So here it is familiar, 4 electrons are there, so we can write 1s2. Then remaining 2 electrons are there. The 2 electrons are filled in the second shell. Second shell that contains S subshell that have 2 electrons. So electronic configuration is 1s2, 2s2. You just add it, 2 plus 2, 4. That is the atomic number. Now you have the idea about the subshell electronic configuration. Now one more thing is there, that is electronic configuration of boron. Its atomic number is 5. Boron, its atomic number is 5. The atomic number is 5, that implies there are 5 electrons. We want to fill the subshell electrons in the subshells. Always the electrons are first filled in the 1s subshell. So we can write 1s2, and it is not possible to write 2s3. Why it is not possible? The maximum number of electrons possible to accommodate in a subshell, it is 2. That's why we have only possible to write what? 2s2. Now 1s2, 2s2. Total electron 2 plus 2. Not here. Here. 2 plus 2. 2 plus 2, 4. Okay, one more electron is remaining, that is filled in the subshell that have energy greater than 2s. The subshell that have energy greater than 2s, it is 2p. So we can write the electronic configuration what? 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. So 1s2, 2s2, 2p1. If you add this, 2 plus 2, 4. 4 plus 1, 5. That is the atomic number. Clear the idea? Next we are skip some atomic numbers, that is to familiarize to you. Then if the atomic number 10, we are writing for what? Neon. Its atomic number is 10. Atomic number 10, that means that have 10 electrons. Then how you write the electronic configuration? Subshell electronic configuration. The electrons at first filled in the 1s subshell, and we can write it as 1s2. And the electrons are filled in the another subshell, that we can write was 2s2. Now the total electrons are filled as 4. 6 more electrons are remaining. 6 more electrons. How many electrons are possible to accommodate in p subshell? That is 6. Then 2s, later which subshell is there? 2p. The 2p have to possible maximum number of electrons is 6. So we can easily write the electronic configuration what? 2p6. Now the subshell electronic configuration, you can read it. It's 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. The total electron 6 plus 2, 8 plus 2, 10. So the atomic number is 10. Get the idea? Next, atomic number 12. Atomic number 12 is magnesium. Okay, if you want to write the subshell electronic configuration, how you write the subshell electronic configuration? We can write the subshell electronic configuration. At first, it is 1s2. By writing these 6 elements electronic configuration, it is very easy to write the first 1s2. Then next one 2s2, and the third one 2p6. 1s2, 2s2, 2p6. 10 electrons are filled in subshells according to their increasing order of energy. Then how many electrons are remaining there? 2 more electrons are remaining. So now first shell is completed. The second shell have 2 subshells, S and P, that also completed. Then there is a chance to fill the electrons in the third shell. The third shell, that is the M shell. The M shell contains 3 subshells, S, P and D. Is it simply right we are SPD like that? No. We want to represent the shell number. So we are writing what? 3S, 3P and 3D. If you compare the energy of these 3S, 3P, 3D, please students, which have the least energy, whether it is for 3S, 3P or 3D? S. The least energy for which subshell? 3s subshell. So the electrons are filled in third shell will be filled at first in the 3s subshell. The electrons are filled in the third subshell. At first it will be filled in the 3s subshell. Third shell electron varumbo adyam electron fill ava 3s ilanu. Okay. So 1s2, 2s2, 2p6 is the subshell electronic configuration. Then we want to give the atomic number is 12. 2 more electrons are remaining. The 2 electrons are filled in the 3s subshell. Then we can write it as 3s2. Okay. Clear the idea? Next, I just skip one more atomic numbers. Then I write here, please listen, the subshell electronic configuration of chlorine. I think it is the chlorine element. Chlorine is very familiar to the students. By writing their electronic configuration, their properties and their nature in the 9th standard and their production also we have studied. So here we only need what? Subshell electronic configuration. What is the atomic number of chlorine? All students will be say it is always 17. Okay, then we want to write the subshell electronic configuration. Yes, start. In which subshell the electrons are filled at first? Yes, we can write what? 1s2, then 2s2, 2p6. Up to there we are very fluent, I think, because 2 plus 2, 4, 4 plus 6, 10. 10 electrons are completed. Then how many electrons are remaining? Yes, 7 electrons are remaining. The next subshell that have the energy is 3s. We can write what? 3s2. Now the 2 electrons are filled. 5 electrons is remaining. After 3s, in which subshell the electrons are filled? Whether in 3p or 3d? After completing these 12 electrons, 5 more electrons is balanced there. In which subshell that will be filled? In 3p or in 3d? What is your opinion? Yes, in 3p, because 3p have the least energy than 3d. So we can write what? 3p 5. Just add it. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12 plus 5, 17. The 17 electrons are completed in their increasing order. Students, one more thing I just familiarized to you. By using this, we can write the electronic configuration also from here. How can you write the electronic configuration? Please check. How many electrons? This is the shell number. This is the first shell. How many electrons are there in the first shell? How many electrons are there? 2. So we can write it as 2. And we are going to the next shell, second shell. So for writing the electronic configuration, we just put a comma. The second shell contain S and P subshell, isn't it? The S and P subshell is there. In S subshell, electrons are 2. In P subshell, there is 6 electrons. Then total electrons in second shell is 2 plus 6, 8. So we can write the electronic configuration. Next shell contain 8 electrons. Okay. Third shell. The next level or next shell, it is third shell. Again we are put a comma. The third shell contain S and P subshells. The S contain 2 electrons and the P subshell contain 5 electrons. Then how many electrons are total number of electrons are there? 2 plus 5, 7. If you write the electronic configuration 2, 8, 7, it is familiar to you, I think. This is the electronic configuration of chlorine. This is the subshell electronic configuration of chlorine. That is easy to write this. Okay, the next, let's for 18, atomic number 18. Atomic number 18 is argon. It's atomic number 18. Okay, we write the subshell electronic configuration. We write it as 1s2, yes, 2s2, 2p6, 3s2, 3p6. Okay, 2, 4, 6, 10, 12 plus 6, 18 electrons are completed. This is the electronic configuration. Up to here, it is very easy to write. The thing other than after 18 also easy, but you want to take some care while writing the atomic number after 19. That is most important thing. Okay, I just going to explain that. To explain that, please listen. It is very important. If you are writing the subshell electronic configuration, we want to check the energy of the subshells. So here I just going to draw a graph. Here is the graph. That graph represents here the shells K, L, M and N. And here in the y-axis, the y-axis represent the energy. The y-axis represent the energy. The K shell contain only one subshell, 1s. Always the least energy for 1s subshell. L shell contain 2 subshells, S and P. While we are writing, it is 2s and 2p. If you write that 2s, 2p, would you get the idea? The 1s have the least energy, 2s have the energy greater than 1s, and the 2p have the energy that's greater than 2s. This is the increasing order of energy. Then third shell, that is a M shell. M shell contain 3 subshells, S, P and D. We can write it as 3s, 3p and 3d. So 3s, 3p and 3d. Okay, if you compare the energy, that is 2p, 3s. If you compare the energy of 2p and 3s, which have the least energy, it is for 2p. That's why after while you are writing the subshell electronic configuration, the electrons are filled in 2p. Then later, the remaining electrons are filled in the 3s subshell. Then very important thing, just look here for the N shell contain 4 subshells, S, P, D and F. You are writing 4S, 4P and 4D. Just write the energy levels. It is here 4S, 4P, 4D and 4F. Look the energy difference here. That is most important. If you compare the energy of 3P and 4S, the energy is least for 3P. There is no doubt. But if you compare the energy of 3D and 4S, the energy of 4S subshell is comparatively less than that of 3D. A least difference in their energy between 3D and 4S subshell. In 3D and 4S subshell, the energy of 4S is slightly less than that of 3D. 3D in the energy relation 4S in energy. Okay, the energy of 4S is slightly less than that of 3D. So the important thing, after completing the 3P subshell, the electrons are filled in the 4S subshell. It is not go to the 3D because of the energy difference. That is the important thing. Children, I think you get the idea. So by using this, we can write the subshell electronic configuration of atomic number element potassium. Its atomic number is 19. Okay, we are going to the subshell electronic configuration. Start. First we write what? 1s2, then 2s2, 2p6, 3s2, 3p6. Up to here we are very familiar these things to write the subshell electronic configuration. Total sum it is 18. We have the atomic number 19. 19 electrons are there. So 1 electron is remaining. The electrons want to fill in the 3D or 4S subshell. That is your opinion. Third shell contain 3 subshells, S, P and D is there, but we have to compare the energy to write the electronic configuration, to fill the electronic configuration. If you compare that, the 3D have the energy greater than that of 4S. So, the electrons want to fill in the 4S after completing 3P. So, 3P complete ചെയ്താൽ 4S ലാണ് electron fill ആവുക. So, we can write the electronic configuration what? 4S1. So, the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. This is the electronic configuration. 2, 4, 10, 12, 18 plus 1, 19. By using this, if you write the electronic configuration, by using the subshell electronic configuration, if you write the electronic configuration, what do you get? The first shell contain 2 electrons. The second shell contain total electron 8 electrons. The third shell contain 2 plus 6, 8 electron. The fourth one that contain 1 electron. So the subshell electronic configuration of 19 is like this. So the electronic configuration is 2881. It is not possible to write the electronic configuration what 289. That is, we are discussed in the previous class. The electronic configuration is not right for the 19 atomic number. It is not possible to write 289. It is only possible to write the electronic configuration is 2881. So the electrons are filled in subshells according to their increasing order. That's why we are writing the electronic configuration like this. Next one, atomic number 19 is discussed. Then atomic number 20, it is for calcium. Atomic number 20, we are write the subshell electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 up to it is 18. Then the 2 more electrons is remaining. The 2 electrons are filled in the 4s subshell. Then we can write it 4s2. Okay. Then atomic number 21. Atomic number 21. We want to write the subshell electronic configuration of 21. That is scandium. Atomic number 21. 21. If you write the subshell electronic configuration, it is 1s2, 2s2. 2p6, 3s2, 3p6. Up to here it is atomic number 18. Then 3 more electrons are remaining. The electrons are filled later. It is 4s. So we can write it as 4s2. Then 1 more electron is there that is filled in the 3d because the energy of 3d is greater than 4s. But 4p have the energy that is greater than that of 3D. Then we can write what? 3D 1. Why I write like this? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 here, 4s2, 3d1 that want to write, but we are writing it as 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. What is the reason we are writing 3d1, 4s2? Because the electrons are filled in subshells. We want to write the subshells that are in same shell. So according to the subshells contained in same shell, we want to write as same 3s, 3p and 3d. That's why we are just change the position into here 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. While writing this also, in which subshell the last electron is filled, they will ask in which subshell the last electron is filled. It is not in 4s, the last electrons are filled in the 3d. Okay, to make the subshells in same energy levels, same shells, we are write like this. Okay, then atomic number 21 is completed. Up to here we are completing this part. Then later the next class we are discuss from 22, and some special cases are there in the subshell electronic configuration for atomic number 24 and 29 that also discussed in the next class. Thank you.